Question 10 is a classic, quite a very difficult problem, but they've guided us through it quite nicely. And the first thing that they've asked us to do is find out the distance from O down to here, O down to C. And the way we're thinking about that is that from O all the way down to here, so the distance all the way down to there, down to T, would be the radius of the big circle. And the distance there to there would be the radius of the small circle. So that bit there from O to C is capital R take away little r. That's this bit here. Capital R take away little r. So then in part B, we're looking at this triangle here. And this triangle is a right-angled triangle because a radius meets a tangent at 90 degrees. We were told the angle there is 2 theta, so this angle here is theta. And I could say that sine of theta equals opposite over hypotenuse, r over capital R minus little r. I'm going to multiply that up. I'm going to take my time. I'm going to multiply it out as well. R sine theta minus little r sine theta equals r. And so we then get what we've been asked for is that r sine theta is r plus r sine theta. Lots of r's there, capitals and small ones. Oh, actually, it does want me to do one more line, doesn't it? That's little r lots of 1 plus sine theta. So there's part B. Now in part C, we've been told that sine theta equals 3/4. So let's put sine theta equals 3/4 into this, shall we? So I've got 3/4 r equals r times 1 plus 3/4 would be 7/4. And so that tells me that r is 7 over 3 little r. Or the other way around, I suppose, little r is 3/7 of big R. And the other thing we've been told is the perimeter of the whole thing. So the perimeter of the whole thing would be r down the first side, r down the second side, and this curved distance here would be r times by theta, which, remember, that whole angle was 2 theta. So, and we've been told that whole thing is equal to 21. So that is capital R lots of, so I've got 2 plus 2 theta equals 21. So capital R is 21 divided by 2 plus 2 theta. So we do need to know what theta is, but they did tell us that sine theta was 3/4. So if I inverse sine that, I can get that theta in radians is 0.848. And so this is 21 divided by 2 lots of that, add 2, is 3.696. And so we're virtually there. Capital R is 5.681 centimetres. Of course, it didn't ask for that. It asked for little r, but that's why we did that bit there. Little r is 3/7 of that, which is 2.43 centimetres. So I think they guided us through by telling us to work out each little bit, but a lovely problem-solving question.